Alright, what's going on, people? So I'm trying to record this video. It's kind of late, so I'm going to talk really quietly. But I had already recorded this video, but I messed up. So this is my second attempt. My my hand movements were just too disconcerting for me. So I was like, what was I doing? I don't know what I was doing. So it was pretty bad. So okay, so this is a problem that I'm solving. Absolute value sort. So this is a sorting problem where basically you are you have to sort this thing, but you have to sort it with like a catch on it, where basically you're sorting it with a different condition. Instead of like sorting something in ascending order, you're sorting something in terms of this comparison, where if the absolute value is smaller, that is going to be on the left side, and the right side, if the absolute value is greater. If the absolute values are the same, but one number is negative, that will be on the left side of a positive number. So you can see that in this example here, so you should get it, -2, and 2 is on the right side, -2, right? Okay, so the first thing I do is, you could use the sorting function inside of Python library, and you could do that. But instead of doing that, what I did was a quick sort, because using the sorting function, like changing the key, that's too easy. So for a coding interview, I don't feel like it shows very much skills. It would show you know some of the library, but let's just implement our own quick sort algorithm to be more proficient. Plus we get this benefit of having O(n) login and O(1). So the basic idea is I shuffle the array, and I shuffle the array because if the pivot point is pointing to a bad element, if it is a bad pivot point, by shuffling it, I reduce the chance of it being consecutive bad pivot points. Like if I'm just given a bunch of arrays that have bad pivot points, that's going to suck. But if I shuffle them, on average, some of them will be good. So this will maybe, on average, reduce the time complexity of n log n on average. Okay. Then we call the quicksort. So here's the quicksort itself, and in the quicksort itself, we have the pivot point. We're going to compute with the partition function, and then quicksort here. So every time we find a pivot point, we're going to quicksort on the left side and quicksort on the right side of it. And we're going to eventually return the array. These are our out of bounds conditions, because if the left is equal to the right, that's an array of size 1, like that's already sorted. Or if the right is smaller than the left, you know, that doesn't make any sense. So we partition here. So the partition function, and this is pretty important, I had made a mistake with this earlier. So the j equals left is basically the condition that we want, because we're only starting with that left pointer, and then I iterates from the left to the right. So the difference between, so this is using the two-pointer approach, and so the j pointer, the idea is that the j pointer here is always going to point to the element, is always going to point to, that's weird, it just happened. Okay, the j is only going to point to the partition point. That's the point of j. It's supposed to point to the partition point, where at the end you'll swap wherever the partition point is with the pivot point, and then everything after the partition point belongs on the right side. Everything before the partition point belongs on the left side, and that's why we do this comparison here. So this comparison is doing the comparison with absolute values. So you know, this is just the logic that you expect. So if it returns true, that means that the number satisfy the condition, and that means that the value we're currently looking at, we want it to be on the left side. That's what the comparison is. Just tell me if I want this value to be on the left side or not. If I want the value to be on the left side, then I should swap it with the current value at the partition point, and kind of move this value before the partition point. That's the whole point of swapping it. And then the partition point moves 1 up. So this point that I swap will now be before the partition point. So that will guarantee that it will be on the left side at the end, because at the end we'll swap the pivot point with the partition, with the value at the partition point. So this should work. Okay, and it does. So yeah, thank you for watching.